So first of all, let's start by reading the problem. The strain gauge shown is used to determine the gauge pressure in a cylindrical steel tank. The tank has an outer diameter of 1250 mm and a wall thickness of 15 mm and is made of steel that has a Young's modulus of 200 gigapascal and a Poisson's ratio of 0.32. The gauge is inclined at an angle of 30 degrees with respect to the longitudinal axis of the tank. Determine the pressure in the tank corresponding to the strain gauge reading. That's value is 290 microstrains. So first of all, we know these are the given values in the question. So using these values, we will be using the concept of thin wall pressure vessel to determine the hoop stress and the longitudinal stress. So we know hoop stress is equal to PR by T, and the radius that is being used here is the inner radius, and we have the in the question we have the outer radius. So to determine the inner radius, we will be using this formula, that is the diameter of the inside is equal to diameter of outside minus 2 times the thickness, because it's a cylindrical tank that has two sides, so 2 times 15, and that will give the diameter of the inner circle as 1220 millimeter. And then we can determine the radius by dividing it by 2 and we will get 610 millimeter. So here we will be using, in this equation we will be using that radius, and that will give us the hoop stress equation as P times 122 by 3 megapascal, and we will be using these values again into the longitudinal stress, and we will be getting this equation. And now using the Hooke's law, we will determine the strains for the hoop stress and the longitudinal stress. So firstly, let's determine for the hoop stress. So to determine the strain for the hoop stress, we have this formula given, and we know by substituting we already know the value of these things. So by substituting their values, we will be getting this equation. And now we don't know the value of P, so P will be taken outside of the equation, as you can see here, as a common. And when you do that one and then substitute the values and calculate it, you will be getting hoop strains equation as 1.708 times 10 raised to minus 4 times P. P is unknown. And now we will do the same for the longitudinal strain. This is the formula for the longitudinal strain, and we know these values inside this one and all of these values here. We will be substituting and we will be getting this equation. And when we get this equation, now we will be bringing out the unknown variable. This is the unknown, we don't know the unknown variable, so we will be bringing it outside like the one for the early equation, and then we will be getting these as the final equation, and that is for the longitudinal strain is equal to 3.66 times 10 raised to minus 5 times the P, the pressure that we do not know. And now we will be using the strain transformation equation. So this is the strain transformation equation, but for this question we know that we do not have any shear stress, so the shear strain will also be subtracted as the value is 0, and we know it is at an angle of 30 degrees. So now we will just be using this part of the equation, and we already know the EA, that is, this is the given value that is in the question, 290 microstrains. And now when we substitute all of these values into this equation, we will be getting this as the final equation. The strain is equal to 7.015 times 10 raised to minus 5 times the pressure that we have to determine, and we already know the value, as I told earlier. This is the value, and now when we substitute that value, 290 times 10 raised to minus 6, we get this as the ultimate equation, and we can determine the pressure. This is the pressure, that unknown pressure, as P is equal to 290 times 10 raised to minus 6 divided by 7.015 times 10 raised to minus 5, and we get the unknown pressure as 4.1339 megapascal, and that is the answer for this question.